Suppose an urn contains 5 white marbles, 3 red marbles, and 2 blue marbles. If 2 marbles are drawn from the urn one at a time without replacement, what is the probability of drawing a blue marble first and then a white marble? So to do this, what we're going to need to do is we're going to have to use our basic rule and definitions of probability. The probability of a blue first and a white second is simply the number of ways to get blue first, white second, divided by the number of ways to draw 2 marbles. Since we talked about first and second here, order definitely makes a difference in this problem. I'm going to use permutations to actually calculate this out. To be able to figure out the number of ways to get blue first, I take the permutation of the 2 blue marbles, we're going to select 1, and I multiply that by the permutation of the 5 white marbles, and I select 1. So these are my 2 choices. I need to choose blue and I need to choose white. On the bottom, I just need to choose 2 marbles from the total of 10, so that's the permutation of 10, 2. Putting in the values, we get permutation of 2, 1 is 2, permutation of 5, 1 is 5, and the permutation of 10, 2 is 90. So when I work that out, it reduces down to 1/9. Now let me go ahead and change this problem slightly. So now instead of saying a blue first, then white, what I want now is just a white marble and a blue marble, and I don't care about the order. There are 2 ways to do this. We can do it with permutations, or we can do it with combinations, but you have to be careful. We still want to figure out the probability of white and blue, but now we need to count the number of ways to get white and blue, and divide that by the number of ways to draw 2 marbles. If I'm assuming that order makes a difference here, I could have a white first and then a blue, or a blue first then a white. That's where these 2 terms come from. The first term here says from the 2 blue, I want to choose 1, and from the 5 white, I want to choose 1. And then over here we switch that around and say now from the 5 white I want 1, and from the 2 blue I want 1. Since order makes a difference, I have to do both ways here. And on the bottom we still have the permutation from the 10 marbles, we're selecting 2. So if I put those values in, I get 2 times 5 plus 5 times 2 divided by 90, which is 2/9. If we hadn't done the previous problem here, you probably would have looked at this and said, oh, this is a combination problem because the order doesn't make a difference. Well, we can do it as a combination problem, but the answer better come out to be the same. So now we'll start in the same place. We'll say the probability of getting a white and a blue marble, except now when we do our counting, we're going to utilize the fact that we're going to do combinations here because order doesn't make a difference. In the denominator now, we're going to say the combination from the 10 marbles, choose 2. But now when we go upstairs and we work out how many ways is there to get the white and how many ways is there to get the blue, I'm going to do combination of 2, choose 1, because from the 2 blue I want 1, and combination of 5, choose 1, because from the 5 white I want 1. Everything's combinations here, so the order doesn't make a bit of difference. So now when I go ahead and put in my values, I get 2 times 5 on the top, and the combination of 10 choose 2 is 45. When I reduce that, that also gives me 2/9. Notice here, I just had to do combinations with 1 term because order doesn't make a difference. When I did the order makes a difference example, I had to do it as blue-white and also white-blue. No matter how I do it, I still get the same answer of 2/9.